The ice and rain protection system allows unrestricted operation of the aircraft in icing conditions and heavy rain. For anti-icing, critical areas of the aircraft are protected by hot air or electrical heating. Hot air from the pneumatic system heats the 4 outboard leading edge slats of each wing in flight. Each engine air intake is anti-iced by an independent air bleed from the high-pressure compressor. The air is supplied through the engine anti-ice valve. Note: in the event of an electrical power supply failure, this valve will automatically open. Electrical heating is provided for windshield anti-icing and cockpit side windows demisting. The angle of attack AOA probes, the total air temperature TAT probes, the pitot probes, and the static ports. Electrical heating elements are fitted on the drain masts. When the electrical system is powered, the drain masts are automatically heated. Note: on the ground, the heat is reduced to prevent injury to ground personnel. An external visual ice indicator with an integrated light is installed between the 2 windshields. An optional ice detection system consisting of 2 separate ice detectors located on the forward lower section of the fuselage may also be installed. All the ice and rain protection controls are located on the overhead panel. On this panel, the crew can select wing and engine anti-ice on or off, and probe window heat on or auto. Memos associated with the use of anti-ice are presented on the engine warning display memo. To improve visibility in rainy conditions, the flight crew can spray a rain repellent liquid. Separate push buttons control the application of the rain repellent on each side of the windshield. Electric wipers are provided for the windshields. They are operated at slow or fast speed through the wiper selector located on the wiper panels. Note: the speed limit with the wipers operating is 230 knots. During the walk-around, you will verify the condition of the drain masts, the pitot, AOA, TAT and ice detection probes. You will also check that all the static ports are clear and that covers are removed. In cold weather conditions, there are additional procedures for exterior inspection and ground de-icing, anti-icing. As part of the preliminary cockpit preparation, you should check that the wipers are off and the probe window heat push-button switch is set to auto. Note: in the auto position, the probes and windows are heated automatically after first engine start. Today, your takeoff is in icing conditions. So let's see what you have to know. Potential icing conditions are defined as outside air temperature below 10 degrees Celsius and visible moisture in the air. Note: the indicated temperature and visible moisture should be used as primary means for turning on the anti-ice system without waiting for a visible ice build-up. The automatic function of the probe window heat system means that in flight the AOA and TAT probes, the pitot, the static ports and the cockpit windows are heated. And on ground, heating is provided when at least one engine is running, except for the TAT probes, which are not heated, and the pitots, which are only heated at low level. Note: you can clear the windows manually prior to engine start by pushing the probe window heat push-button switch to the on position. Because you are in potential icing conditions, the anti-ice system must be selected on. Please select the engine anti-ice system on. Select the engine 1 anti-ice. Notice that the amber fault light in the engine 1 anti-ice push-button switch illuminates momentarily during the valve transit, and then the fault light disappears and the blue on light illuminates. As soon as one engine anti-ice push-button switch is on, the engine anti-ice memo appears in green on the engine warning display, and the ignition memo appears in green, indicating that continuous ignition is automatically activated. The idle N1 is automatically increased to give better protection against flameout. N1 limit, the amber tick, is automatically reduced. Continue by selecting the engine 2 anti-ice. Both engine air intakes are now being anti-iced. Continue the anti-ice procedure by setting the wing anti-ice system on. The wing anti-ice push-button switch controls the wing anti-ice system on both wings simultaneously. Note: use of APU bleed is not authorized for wing anti-icing. Please select wing anti-ice. Notice that the fault light in the wing anti-ice push-button switch illuminates amber momentarily during the valve transit. The fault light is replaced by the blue on light. The wing anti-ice memo appears on the engine warning display. N1 limit, amber tick, is automatically reduced, and the idle N1 is automatically increased. We have called the ECAM bleed page for you. Observe that the anti-ice white indications are displayed, meaning that the wing anti-ice push-button switch has been set to on. And the green triangles are displayed, indicating that the wing anti-ice valves are open. Observe that 30 seconds after the wing anti-ice push-button switch has been set to on, the wing anti-ice valve indications disappear. This is because on ground, the wing anti-ice valves close automatically to prevent an overheat of the slats. This is the ground test sequence. At liftoff, the valves will reopen automatically and the slats will be heated again. Note: use caution when taxiing with engine anti-icing on, because ground idle is increased. You are now in cruise, clear of icing conditions. If you do not expect the conditions to change, anti-icing systems should be switched off. Note, if the ice detection system is installed, an ice not detected memo indicates that no ice has been detected for approximately 3 minutes. We have called the ECAM bleed page for you. First, switch the wing anti-ice off. Observe that the wing anti-ice message on the memo display and all the wing anti-ice indications on the ECAM bleed page have disappeared. Continue by switching off the engine anti-ice systems. First, switch engine 1 anti-ice off. Now switch engine 2 anti-ice off. During climb or cruise, the anti-ice systems may also be switched off when the SAT is below -40 degrees Celsius, even if there is visible moisture. We are about to commence the descent. Because potential icing conditions are expected, the engine anti-ice system is switched on prior to starting the descent, even if the SAT is below -40 degrees Celsius. We will switch the engine anti-ice on for you. You are now in descent. The engine anti-ice system is on. You observe ice accretion on the visual ice indicator. We have called the ECAM bleed page for you. Switch the wing anti-ice on. Observe that the wing anti-ice indications are displayed on the ECAM bleed page, and the wing ice memo appears on the engine warning display. Note, because the engine idle speed is increased when the anti-ice system is used, the rate of descent is reduced. You are now taxiing to the gate. The wing anti-ice valves have closed automatically at touchdown, but the engine anti-ice will stay on until you switch it off just before engine shutdown. Note, as the ground idle is increased, take care to control the taxi speed, especially on wet or slippery surfaces. Turn the wing anti-ice off. As the approach was made in icing conditions, do not retract the flaps and slats until after engine shutdown. Wait until they have been checked by ground personnel to ensure that they are clear of obstructing ice. Note, during extended ground idle operation, periodic engine run-up to 50% N1 may be performed to remove any ice from the spinner and the fan blades. For ground operations in heavy rain, refer to your FCOM. This is a demonstration of an in-flight failure of the Engine 1 anti-ice valve. You are currently flying at your cruise level. Everything is normal. Click on the forward arrow to activate the failure. On the engine warning display, read the title of the failure. In this example, the blue line advises you to avoid icing conditions. Notice that no system page is called. Having noted the advice, and after review and confirmation from the pilot flying, clear anti-ice. The status page is now displayed and reminds you to avoid icing conditions. The inoperative system is the engine 1 anti-ice valve. After review and confirmation from the pilot flying, clear status. ECAM action completed. Let's continue with an in-flight captain's pitot probe heating failure. You are still in cruise, everything is back to normal. Click on the forward arrow to activate the failure. On the engine warning display, read the title of the failure. This time, the captain's pitot probe heating is not operating. This could lead to ice build-up on the captain's pitot, causing incorrect speed information. To ensure valid information to the captain's instruments, the air data source should be changed. The pilot flying will ask you to perform the ECAM actions. Perform ECAM action. By selecting Captain on 3 on the Air Data selector, ADR3 replaces ADR1 to provide valid data to the captain's instruments. Note, air data switching should not be selected to Captain on 3 if ADR3 is not available. After review and confirmation from the pilot flying, clear anti-ice. On the engine warning display, the memo message Switching Panel is displayed to remind you that the captain's ADR has been switched. The status page is displayed. The inoperative system is the captain's pitot heating. After review and confirmation from the pilot flying, clear status. ECAM action completed. You are continuing the flight and everything is back to normal. Click on the forward arrow to continue. On the engine warning display, read the title of the message. Ice has been detected by at least one detector. The pilot flying will ask you to perform the ECAM actions. Perform ECAM action. After review and confirmation from the pilot flying, clear anti-ice. Click on the forward arrow to continue. You are now in heavy icing conditions. On the engine warning display, read the title of the message. The pilot flying will ask you to perform the ECAM actions. Perform ECAM action. On the engine warning display, read the title of the failure. The ECAM caution, anti-ice wing valve not open, appears, meaning that at least one wing anti-ice valve has not opened after switching the system on. Before applying the ECAM actions, you should clear the first message. After review and confirmation from the pilot flying, clear anti-ice. Notice the ECAM bleed page is called automatically. On the ECAM bleed page, there are no green arrows on the left side, meaning that both left wing anti-ice valves are not open. Notice the amber anti-ice indication. Observe that the fault light in the wing anti-ice push-button switch remains illuminated. The pilot flying will ask you to perform the ECAM actions. Perform ECAM action. On the bleed page, all wing anti-ice indications have disappeared, meaning that wing anti-icing is no longer operating. The ECAM advises you to avoid icing conditions. After review and confirmation from the pilot flying, clear anti-ice. The status page is called. The message "Avoid icing conditions" is displayed. The inoperative system is the wing anti-ice. After review and confirmation from the pilot flying, clear status. ECAM action completed. You are in cruise. The anti-ice systems are operating, and you want to switch off the wing anti-ice system. Please do it now. Observe that, on the engine warning display, the ECAM cautions anti-ice left inner wing open and anti-ice left outer wing open appear, meaning that the valves are stuck open. On the ECAM bleed page, the amber arrows are displayed, indicating that the valves are open with the wing anti-ice push-button switch in the off position. On the anti-ice panel, the amber fault light illuminates because there is a disagreement between the selected and actual position of the valves. According to the indications, in flight, the wing anti-ice is available and can be selected on if required. As the valves are stuck open, the left wing anti-icing is continuously on. After review and confirmation from the pilot flying, clear anti-ice. Go ahead and clear the second message. Clear anti-ice. The message "Wing anti-ice available in flight" is displayed on the status page. After review and confirmation from the pilot flying, clear status. ECAM action completed. However, the fault remains. Click on the forward arrow to continue. Let's see the effect of the fault after landing. Click on the forward arrow to continue. An automatic recall of the failure has occurred, with a new procedure because you are now on ground. The ECAM action is to switch off engine 1 bleed. This is to avoid overheating the left wing by isolating the air supply from the wing anti-ice system. The pilot flying will ask you to perform the ECAM actions. Perform ECAM action. The engine 1 bleed valve is closed, as shown by the white off light illuminated on the corresponding push-button switch, and the indications on the ECAM bleed page. Note, as the left wing is affected, the APU bleed should not be used. No further action is required. After review and confirmation from the pilot flying, clear anti-ice. Please carry on. Clear anti-ice. The status page is called repeating the message you had on the engine warning display. The inoperative systems are Pack 1 and Engine 1 bleed. After review and confirmation from the pilot flying, clear status. ECAM action completed.